welcome to the Saturday night Promethean Pack class. Tonight is the fourth part of the five-part series that LaRouche produced in 1984, 40 years ago, for his presidential campaign of that year on his principles of physical economy, called The Power of Labor. We showed in the last 3 weeks the first three parts of this video lecture series, and you can find those at the Promethean Action website. Tonight we'll show the fourth part, and next week we'll complete the video series with the fifth part. Now, in the first three parts, LaRouche showed, based on his discoveries in physical economy, how a healthy economy is based on increases in potential relative population density, based on increases in energy flux density, and based on an increase of what he called the free energy ratio, or the rate of profit, and showed that these parameters, which can be defined quite precisely, actually reflect an underlying characteristic of what he called in this tape negentropy, which he later called anti-entropy. And the term negentropy or anti-entropy refers to a opposite of the second law of thermodynamics, which states that the entropy of the universe is always increasing. And this concept comes basically out of the thermodynamics of Rudolf Clausius, who invented that term, and also Lord Kelvin, which basically states that the universe tends from states of order to disorder, or processes in the universe tend to go from states of high organization to states of equilibrium, like in a simple closed system of heat, where heat will flow from hot to cold and tend towards a state of small fluctuations of equilibrium. Like when you put an ice cube into a cup of coffee, the coffee gets cooler, the ice cube gets warmer, and eventually it becomes all one temperature. And according to Clausius and Kelvin, and also most modern economists, this is how an economy functions. It's always, you want to have the economy functioning in a steady state, where the buying and selling and economic transactions all equals out to an equal state. And what LaRouche pointed out and showed, and I think proved definitively, is that when the economy is in that state, you have a decline in the potential relative population density, which translates physically into decline in the conditions of life for the population, and ultimately into depopulation. That's an entropic process. And that for in terms of the historical record, you see exactly the opposite effect expressed by the historical development of mankind, which is characterized by an increase in potential relative population density, and also an increase in overall population. Today, of course, we're facing a situation where you are seeing a decline in population in most advanced countries, and actually through most of the world, except with a few exceptions. And this is quite dangerous, and many people are sounding the alarm about it. So in effect, despite the fact that we've had tremendous increases in technology and capability for mankind over the last decade, last 100 years or 200 years, so to say, policy, especially in the last 30, 40 years, has produced a net decrease in economic capability. Therefore, we're seeing a quite dangerous situation with respect to the future of mankind. That is, the economy has been largely entropic, and we need to make it negentropic. Now, in today's presentation, which will begin right in a few seconds here, LaRouche shows that this negentropic characteristic of a healthy functioning economy, physical economy, is actually reflective of a general characteristic of the universe as a whole, contrary to what Clausius and Lord Kelvin and most modern economists believe. That is, that what you see mankind doing in terms of producing healthy economic activity is actually the characteristic of the universe as a whole. And in tonight's presentation, LaRouche will describe some of this evidence in this regard with respect to living processes and astrophysical processes. And next week, he will explore this even further in terms of the general characteristics of the human mind. So what I'd like to do is for Tony to start the class. We'll watch the tape, the fourth section, and then we'll come back and I will initiate some discussion with some updates, because this presentation was made 40 years ago, and LaRouche did a lot of work over the intervening period, but also there has been a lot of developments in other areas of science and technology that open up this point in a very new way. So why don't we watch, and then we can open it up for discussion and see where we go from there. So Tony, why don't you start the tape? We'll watch that and then we'll come back in.
Be fruitful and multiply and replenish the earth and subdue it.
The following program is one of 5 parts of The Power of Labor, an educational special on economic science written by Democratic presidential candidate Lyndon LaRouche. The Power of Labor was produced for classroom use and is intended to be accompanied by Mr. LaRouche's textbook, So You Wish to Learn All About Economics.
Now I must ask you to concentrate your thinking. Within the point I've just made to you, there's one of the most fundamental principles of scientific method in general. It is the everyday definition of a fact, that a fact is the name we use to identify some object toward which we are pointing. In other words, it is commonplace practice to associate facts with nouns, or with phrases and statements whose referent in experience is defined in the same way as a noun. Formal logic, so-called, is based on the axiomatic assumption that all facts are to be defined in no other manner but this. However, the majority of these figures of science, responsible for what are called fundamental discoveries of science, used a different definition of fact. The first recorded discussion of this issue of method is from the writings of the founder of the study of the principles of language, a great Sanskrit scholar from about the 5th century BC, named Panini. Panini insisted that all terms of language and the structure of language in general are derived from verbs, not nouns. In other words, a true fact can never be described by a noun. A true fact of human experience is always the experience of some physical action, an experience which can never be described by a noun. Physical action is described by use of transitive verbs. What we experience is a change in the physical space observed. All experience is either of the form of the statement, A becomes B or A did not become B. In other words, all experience occurs as either a change or a lack of change within a definite amount of space and time. Matter has the form and content of a physical transformation in a definite minimal amount of space-time. Any attempt to introduce the ideas of matter by itself, or space by itself, or time by itself is an absurdity. Only transformations in physical space-time have real meaning. Look at our mathematical definition of work as a statement of a transformation in physical space-time. The volume defined by the iterative elliptical function has the physical meaning of a transformation of the economic process from the potential relative population density at A to the increased potential relative population density at B. Let us express this transformation by the symbols P parenthesis sub A and P parenthesis sub B. The transformation occurs in space and time. So all definitions of fact concerning economic processes must be of the mathematical form of processes involving change of potential in physical space-time. Let us choose an example of this, a very relevant sort of simple statement. The statement is, this is a living process. Let us take this statement out of the noun form and restate the same fact of experience by using the same geometrical method we have employed to define work. It is our best information today that the first persons to succeed in defining the meaning of the term living process were Leonardo da Vinci and his colleague Luca Pacioli. They reported quite accurately that all living processes have one geometrical property in common. The proportions of growth and function of living processes are in self-similar proportion. And this proportioning is congruent with a very special geometrical rule called the golden section. All growth functions associated with living processes are harmonically proportioned according to the principle of the golden section. This is one of the simplest of all cases. The shell of the chambered nautilus, or the shell of the conch, or more common sea snail. Next slide. The same harmonic ratios govern the growth of all plants. Next slide. The human form, like the form of all animals, is determined by the same harmonic principles of geometry. There's nothing mystical about this function of the golden section. Let us remove the mystery by examining another case in which the golden section determines something commonly experienced, the well-tempered musical scale of Bach. The determination of the precise values for the well-tempered scale begins by constructing a self-similar spiral on a cone. Next slide. Now we're seeing the shadow which the cone spiral makes on the circular base of the cone. It looks very much like the shape of the snail's shell. Next slide. Now we've drawn a radius from the center of the circular base, cutting through the area of the spiral on the circular base. The arm of the spiral cuts the radius into lengths. The lengths increase as we go outward from the center of the circle. If you compare the lengths of the radius cut off by the spiral, you'll observe that the ratios of the lengths are in self-similar proportions. Next slide. Here, for reasons of topology, which we shall not discuss here, we have cut the circular base of the cone into 12 equal sectors. This time, let us look at the lengths of the arm of the spiral between the points at which the spiral arm intersects the radii. Imagine that the spiral is like a vibrating string, such as the string of a violin or cello. Imagine that the finger of the violinist or cellist is pressed on the string, and at each point a radius intersects the spiral. You can prove to yourself that the tones heard will be in exactly the proportions of the well-tempered musical scale. The point we are illustrating is this. Wherever the golden section appears as the geometrical characteristic of a process which we see with our sense perceptions, we know that the process is a reflection of a self-similar conical spiral in higher order physical space. We have illustrated two things here. Let us take the 2 points in order. First, the noun, life, must be translated into the form of a transitive verb. We have indicated by the preceding examples that the fact that living processes have the form of the golden section means that the living process is a transformation in the same form as increase of potential relative population density of a self-similar conic spiral action. The word life and the term living process must be translated into terms which designate self-similar conic spiral action, a term which references this species of transformation of potential in physical space-time. It is to be stressed that the conventional notion of biology is associated with terms such as organic chemistry. Organic chemistry has the same relationship to life as the pathologist's dissecting room has to the living form of what is dissected. Biology used in this way does not refer directly to the phenomenon of life. Only statements consistent with the kinds of transformation characterized by the golden section actually reference the phenomena of life as life. This is an excellent illustration of the fallacy of using nouns instead of transitive verbs to identify what are treated as facts. The comparison we just made between increase of potential relative population density and life implies the proper definition of the term negentropy. Therefore, we throw away the definitions of the term negentropy, which are commonly used in discussions of statistical thermodynamics and so-called information theory. The only proper definition of negentropy is that supplied by living processes, including successfully growing economies. For most of you, what I'm about to report now will be considered not only unbelievable, but shockingly unbelievable. Nonetheless, for reasons of proof I shall merely identify here, what I have to say is not only true, but has been proven so conclusively by modern science, beginning with the work of Johannes Kepler, that any contrary opinion is necessarily a scientific absurdity. We are now entering into an aspect of physical science in which physical science as such, the productive powers of labor, and morality become one and the same truth, as the passage from Genesis implies. Modern mathematical physics was founded by the astrophysicist Johannes Kepler at the beginning of the 17th century. Kepler did more than to discover the fundamental laws of astronomy. Although Kepler's discoveries do not represent a fully perfected statement of the universal laws of creation, they are a first approximation of those laws and are accurate to the degree that all opponents of Kepler over the recent 400 years have proven to be absurd in their choice of disagreements. It should be obvious that there could not be a universally applicable kind of mathematical physics unless that mathematics were proven to be consistent with the laws of the universe, which are everywhere fundamentally true and efficient. Thus, Kepler must be identified as the founder of mathematical physics. Kepler's great discoveries began chiefly from two starting points: the work of Nicholas of Cusa and of Luca, Pacioli, and Leonardo da Vinci. From Cusa, Kepler obtained two things indispensable for his work: Cusa's methods for mathematical physics investigation and Cusa's solar hypothesis. Kepler's solar hypothesis is a corrected version of Cusa's, the most essential of the work of Pacioli and Leonardo for Kepler's own discoveries were Pacioli's and Leonardo's work in geometry, and the demonstration that all living processes are ordered by the principle of the golden section. The story that Copernicus first presented a model of the solar system with the sun at the center is a myth and a legend. In the last section of Dante Alighieri's famous Commedia, for example, the planets moving in circular orbits around the sun were presented and made famous about 200 years before Copernicus. During the middle of the 15th century, Cusa argued for the solar hypothesis used later by Copernicus. Kepler corrected Cusa's solar hypothesis by combining the discoveries of Cusa with those of Pacioli and Leonardo. It is necessary to identify the most essential of the discoveries of Cusa and Leonardo as employed later by Kepler to found mathematical physics. The ancient foundations of modern European mathematical physics are located chiefly in one of the most influential of Plato's dialogues, the Timaeus. It was Cusa first and Pacioli after him who discovered a fresh proof for the physics of the Timaeus. As we have noted earlier, Cusa rediscovered what is called the isoperimetric principle, the principle of geometry which is the basis for Leibniz's principle of least action. With aid of Cusa's rediscovery of the isoperimetric principle, Luca Pacioli was able to master the central mathematical feature of Plato's Timaeus. Plato centered the writing of the Timaeus around the mathematical proof that with ruler and compass alone, only 5 kinds of regular solids can be constructed. The first and simplest of the 5 Platonic solids is the tetrahedron. Each side of the tetrahedron is an equilateral triangle. Next, the second is the cube, constructed of squares. Next, the third is the 8-sided octahedron, constructed of regular triangles, like the tetrahedron. Next, the fourth is the most important of the 5 Platonic solids. It is the 12-sided dodecahedron, each side a regular pentagon. In constructing either a regular pentagon or a duodecahedron by ruler and compass methods of construction, we must first construct the golden section from the circle. Next, finally, the 5th Platonic solid is the 20-sided icosahedron, each of whose sides is a regular triangle. So, we have the 5 Platonic solids. Luca Pacioli wrote a book, probably in collaboration with his colleague Leonardo, a book named in English translation, The Divine Proportions. In this book, Pacioli presented a proof that only these 5 regular solids could be constructed by ruler and compass methods. Later, during the 18th century, the great mathematician Leonhard Euler developed a much stronger proof and derived the principles of a branch of mathematics called topology from this proof. Euler proved that all of the other 4 Platonic solids are created simply by constructing a decahedron first. This means a dodecahedron is a simple, unique figure which expresses the absolute limits for construction by ruler and compass methods. Since the dodecahedron is constructed by means of construction of the golden section, the golden section expresses a fundamental law of geometry and therefore a fundamental law of mathematical physics too. Kepler constructed his mathematical model of the solar system's laws on the basis of the interrelationships among the 5 Platonic solids. In other words, Kepler constructed mathematical physics entirely on the basis of the golden section as the starting point. This brings us to the shockingly truthful fact about the universe. All living processes are distinguished from non-living by the fact that living processes are congruent with the golden section. Kepler proved that the laws of astronomy are also congruent with the golden section. This means that the universe as a whole is a negentropic process. This shocking truth of Kepler's was challenged by many notable figures later. The founder of British speculative Freemasonry, Robert Flood, wrote a major attack against Kepler's work. Galileo attempted to destroy the influence of Kepler's work, and so did René Descartes and Isaac Newton. All of these criticisms of Kepler were proven to be absurd by Carl Gauss. The case of the asteroids provided the conclusive proof that Kepler was correct and his critics absurd. Kepler's proof demands the existence of a planetary orbit between the orbits of Mars and of Jupiter. Kepler elaborated the reasons such a formerly existing planet must have been destroyed and gave the harmonic values of the orbit for this planet. Gauss was the first to prove that the newly discovered asteroids, nearly 2 centuries later, had the orbital values specified by Kepler for the exploded planet. The fact that Kepler's method for defining the laws of astronomy required exactly this orbit for an exploded planet is the toughest, most rigorous kind of empirical proof that all criticisms of his mathematical physics by Flood, Descartes, Newton, and others are nonsense. The chief criticism made against Kepler by Isaac Newton and others was that Kepler's calculations of elliptic orbits of the planets was mathematically unsound, and that therefore Kepler's laws of astronomy were wrong. Carl Gauss also settled this issue absolutely in Kepler's favor. In the figure on your screen, you see what should now be familiar to you as the elliptic cross-section of one cycle of a self-similar conic spiral. Imagine the cone standing on a piece of paper, and see the image which the ellipse inside the cone casts upon the paper. One focus of the ellipse on the paper is our sun. Now you see our Earth orbiting within the cone, and the image of the Earth orbiting around the sun as this appears on the paper. Let us discuss now an important fact about what we're seeing. Without going into the details of the proof here, the fact that the solar orbits are of this elliptical form shows that the cause of the organization of our solar system is that the universe in which the solar system exists is a negentropic universe. The self-similar conic spiral action is the cause for the characteristics of the solar system. The projected result of this is the solar system as it appears to our senses. In other words, the universe is doing negentropic work on the solar system. Kepler assumed that the work being done on the solar system by the universe was of the form of electromagnetic rotation. This was the conception which Kepler worked out with the help of the work of a great English scientist, William Gilbert, the discoverer of many of the principles of electromagnetism. In Kepler's calculations for gravitational force, which Newton reinterpreted algebraically to state formulations for universal gravitation, gravitational force arises from doing work against the electromagnetic field of rotation. In other words, in every leading respect, the laws of astronomy are characterized by negentropy. This is directly opposite to conventional opinion today. It is usually argued that the universe as a whole is made up of dead things, and that living processes must be explained in terms of mathematical physics based on the arithmetic of dead objects. For reasons already recognized by Newton and debated between Newton and Leibniz, a universe of dead things, the universe as described by Descartes, the universe as a whole is running down, winding down, like the mainspring of a mechanical clock. In other words, it is commonly assumed that the universe as a whole is entropic. It should be clear that any mathematical physics which assumes that the universe is entropic is an incompetent mathematical physics. As we've indicated, Kepler's proof that the universe is negentropic has been repeatedly shown to be universally and uniquely valid over the centuries. Everyone who assumed that the universe is entropic made that assumption in defiance of conclusive empirical evidence. Therefore, all entropic mathematical physics is not merely in error, but is a product of willful incompetence. We now combine our discussions of the meaning of fact and of negentropy. First, for reasons we have shown, things as such are not facts. In science, the term fact should never be used to mean anything but a transformation in physical space-time. All transformations are primarily of three general categories: negentropic, energetic, or entropic. So far, we have shown only the simplest variety of negentropic transformation. There are more complicated varieties of negentropic transformations, but the principle remains the same as in the simplest case. Entropic actions are equivalent to a negative, self-similar conic function. All particular kinds of transformations are treated as subspecies of one of the three principal categories of transformations. There are various subspecies of negentropic action, various subspecies of energetic action, and various subspecies of entropic action. Mathematical physics, properly defined, is the study of these subspecies of transformations and their interconnections within a negentropic universe. Your most important problem in understanding the universe as we've described it is your attempt to reconcile what we have developed so far with the commonplace belief that objects of perception are self-evidently existing things, the noun view of experience. This noun view of experience was the basis for Descartes' image of the universe. Naive belief assumes that objects move around in empty space and interact with each other. In the picture of the universe we have described, the thing is recognized as existing, but we interpret such objects in a different way than Descartes does. First, for us, all objects have been created by a universal negentropic process. Mathematically, this act of creation resembles the creation of a singularity by conic, self-similar spiral action, as we described that earlier here. These singularities are also used up later on, used up as raw material for the creation of new singularities. So in our approach to mathematical physics, we define objects mathematically as we defined energy in study of economic processes. We define an object primarily by comparing the work of its creation and the work obtained by its destruction. The proper definition of any object is based on studying the characteristics of the object in terms of reference to both its creation and its destruction. In other words, we do not treat objects as finished things. We treat objects as ephemeral moments of transition between two work processes. Naturally, as measured in human lifetimes, the ephemeral object may have an existence measured in billions of years. From our subjective standpoint, such long-lived objects appear to be permanent existences within the universe. From the standpoint of the limitless existence of a being coextensive with our universe, as Christian theology defines God to be, the proper view of all objects as merely ephemerals is the natural viewpoint. Sooner or later, if after billions of years, objects once created will ultimately be destroyed by being used up in some way. If we wish to understand the universe, we must always instruct our minds to attempt to see the universe and its species and subspecies of transformations as that universal being must view the universe. In a moment or so, we shall show how any human being can train his or her mind to look at the universe in the way we have indicated here. First, we must clean up one loose end concerning mathematical physics of increase of potential relative population density. Potential population density is quite obviously a way of measuring mankind's relationship to nature as a whole. The fact that less and less land area is required by society to sustain an average individual means that the intensity of mankind's mastery of nature has been increased. For reasons we have indicated so far, this means that the energy level per capita has been increased. The energy and energy flux density are increased. This energy is produced. This signifies greater work output per capita in producing this energy and energy flux density. Also, the energy flux density at which this energy produced is applied is increased. This meaning of technology must be employed throughout economic sciences practice.
Rose, put on your video.
Okay. Well, I think the characterization of Lind there, that what he was developing is shockingly unbelievable. I hope that sinks in, because it is quite shocking to the way most people think today, and definitely shocking to the way most of science and economics is done today. Most of science actually is based on the upside down version of what LaRouche said. If you look at those three parts, those three types of processes LaRouche talked about, negentropic, energetic, and entropic. In LaRouche's view, the negentropic, which is expressed, as he showed, in physical economy and in living processes, and in the astrophysical domain and in other areas of physics, is the base case, is the general case, is the overall characteristic of the universe. And the two other versions, energetic, which basically means that there is no increase or decrease in energy, versus entropy, which assumes an increase in entropy, are either at best special cases of an overall negentropic process. So that's a very hard question to grasp, but I think that question is really the fundamental question that both science and citizens have to grasp if they want to understand physical economy. Now, this conflict between what LaRouche is saying about the nature of the universe here, as derived from his understanding of physical economy, and the generally accepted mathematics view of science and economy, has developed quite a bit in the last 40 years since this tape was made. There's a growing number of scientists today who have realized that the generally accepted entropic or merely energetic view of living processes and physical processes cannot explain the observable basic functioning of life and even physical phenomena. And this has led now to a growing number of scientists who are casting about to try and begin to understand life and physics and science from a completely different view. Unfortunately, very few of them have the understanding that LaRouche laid out here of negentropy, or anti-entropy, as he would later call it, or dunotropy, as I call it, is the fundamental characteristic of the universe. So there's a lot of work we have to do to get this point across. But nevertheless, it's really quite exciting that there's a realization now that in order to understand life and physical processes as well as economics, we have to reject the reductionist idea that is prevalent and understand exactly what LaRouche is saying. I'll give you an example of this that is quite relevant and which everybody is familiar with, is the current excitement and financial bubble around so-called artificial intelligence, which assumes that a machine, a computer, which is fundamentally an entropic process, can replicate the characteristics of the human mind. Anybody who's played around with the artificial intelligence, large language models and so forth, can quickly realize that this is not the case. Now, some of this has been attributed that they just need to be trained more and have more data and more sophisticated software. I would say that's really not true, that the artificial intelligence is axiomatically flawed. But if you look at the predominant view in neuroscience, there's an attempt to try and explain what the human mind does by looking at what the brain does and try and interpret the brain's activity as if it were a entropic computer. And this is completely insane. The brain is it first of all is not a solid state process. It's a living process based on other nonlinear physical processes of which we understand very little of. And all the efforts to try and locate within the brain's activity ideas that are solely aspects of consciousness or cognitive activity fail. In other words, you cannot explain the creation of a new idea, or even something as simple as the taste of chocolate, as one researcher, David Hoffman, has has talked about, you cannot locate that in anything in the physical substrate of the brain. That in fact, you have to reverse the whole process and start with the mind and how the mind functions, which of course is the province of art primarily. And from there, realize that it's the immaterial functioning of the mind which determines the physical characteristics of the brain. There are many other examples of this. I just put that one out because I think it's one that's both in the immediate public controversy and also one which reflects what LaRouche is talking about here. So what we're talking about in the science of physical economy and LaRouche's ideas here is not some type of economic textbook, but an actual insight into how man's understanding of nature and his role in the universe and his role in society has to be reorganized and re-understood from the standpoint of negentropy. And I would also argue that this view that LaRouche put forward here, as he himself identifies by citing the book of Genesis, is also consistent with the basic principles of Judeo-Christian thinking. And I guess I'll leave it at that right now. Maybe we can open up for questions, or if Tony has
Well, one thing I wanted to ask if that, I mean, Lynn briefly focused on, he only had a minute to do it, the Carl Gauss's vindication of Kepler's astrophysics through the newly discovered asteroids at the end of the 18th century, beginning of the 19th century. And you were personally involved in a research project on that, which resulted in a paper. And I found the whole story incredibly inspiring and convincing. And I thought maybe viewers would benefit if you sketched it briefly and its significance.
Yeah, sure. Let me elaborate a little bit on what LaRouche developed about Kepler's ideas, because Kepler, which I think will help make this clear, because Kepler did, and I would, it's really just a crime that basic education in science today doesn't begin with Kepler. I mean, maybe you should have some, Greek science and so forth, but to really get into science and understand what it is, and students, especially even starting in the elementary school and middle school level, really need to benefit from the experience of studying Kepler. Because Kepler's first book, called The Mysterium Cosmographicum, the
Mystery of the Universe.
Mystery of the Universe, he starts by, he published it twice, once in the 1590s and later, about 20-30 years later, where he wrote a new introduction reflecting on the implications of it. But in that book, Kepler asked the question, why there were 5 visible planets at the time. Why are there 5 planets, and why are they where they are? And he, in that paper, said, developed the idea, and it's very fascinating the way he developed it, that the orbits of the planets, the size of the relative orbits, and the numbers of the planets, that is 5, roughly correspond to the equators of spheres. And we showed a picture of this, of a model of this, that are inscribed and circumscribed in the 5 regular solids. Now, LaRouche laid out one thing about the 5 regular solids, but there's something else which he didn't mention, which is very important, that Kepler also talks about, and that's the idea of what he calls congruence. Congruence, Kepler points out, is not what you learn in school, that 2 triangles are congruent if they're actually equal. No, congruence is the Latin translation for the Greek word harmony. And that means how things fit together. Of course, this is relevant for what LaRouche pointed out about music. So on a flat surface, you can fit squares together, you can fit triangles together, you can fit hexagons together, but you can't fit pentagons together. They'll leave a gap, and any other plane figure. But on a sphere, which is this, as LaRouche showed, is a kind of an isoparametric principle. It's the simplest, it's the volume, the shape which encompasses the greatest possible volume in the smallest possible surface area. It's a unique fundamental shape. There you can put the the dodecahedron, square, and triangles together as the only equal divisions of the sphere. And so it means that the characteristic of the 5 regular solids is not a characteristic derived from plane figures, but is a characteristic derived from the sphere. Now, if you were to look at a sphere, it would appear to have no divisions whatsoever in it. It's the same everywhere. But yet there's something intrinsic to the curvature, which is outside the domain of sense perception. You can't see it until you try to do something to the sphere, like divide it into equal parts. And there you discover that that curvature of the sphere has embedded within it a characteristic that limits its divisions into these 5 regular solids. And then Kepler showed that those 5 regular solids, these were discovered by the Pythagoreans, the ancient Greeks, and probably more ancient societies. But Kepler is the first one that we know of who actually discovered the relationship between these 5 regular solids and the actual development of the universe. And in his Mysterium Cosmographicum, Kepler says, it's as if art is imitating nature. It's as if God looked to art, i.e. the creative powers of man, to create the world in such a way that it would conform to the idea of beauty that arises in the mind of man. Again, he's relating the creative powers of the mind to the actual physical construction of the characteristic of the universe as a whole. Now, in this first assumption Kepler had, the equators of those spheres are circles. And Kepler later showed in his New Astronomy that the planetary orbits were not circles, but were ellipses. This is a very important study, which everybody should learn how Kepler discovered this. But then he asked the question, what makes these ellipses and not some other ellipses? And in one of his later works, The Harmonies of the Universe, Kepler showed that the relationship between these ellipses corresponds very closely to the intervals of the musical scale that LaRouche described in that spiral action question example that he did. Now, Kepler already in the Mysterium Cosmographicum poses the question, when you look at these principles that order the solar system, and he said you have to think about the solar system not as a fixed thing, like what LaRouche was talking about in this video about facts. You can't think about facts as a noun, because we look at the solar system and you think, well, this is a fixed set of relations, but it's not. This is changing. The solar system developed into this characteristic that it has that we observe from something else, and it's developing into something in the future. It's a developing process, very slow compared to our lifetime, but not necessarily slow from the standpoint of astrophysical time. So the solar system and the characteristics of the solar system in LaRouche's language that we just heard is a verb, not a noun. So in this relationship, you see that there's a very large gap between Mars and Jupiter. And the harmonic relationships that Kepler discovered that exists between the orbit of Mars and the orbit of Jupiter conform to a very dissonant interval in the musical scale, the interval which is often called, which I call the Lydian interval. It's sometimes called the devil's interval because it was banned from medieval music, but it became integral in the development of Renaissance music, and of course, especially the music of Bach. It's the interval between in the key of C and F sharp, or the half tone between the tonic and the half tone between the fourth and the fifth note in the scale. Now, Kepler hypothesized that there may have been at one time a planet in this interval, and that planet, because this was so dissonant, was not able to remain, either not able to form properly, or what may be formed and exploded. Now, none of the parts of this planet were known to Kepler or ever observed. But in 1801, which was on January, literally January 1st of 1801, the first day of the 19th century, an Italian astronomer, Piazzi, was observing this region of the sky with his telescope, and he found what appeared to be a new planet. It was very close to the sun, and so he only had I think 41 days of observations of this planet, which is a very small arc. If I'm correct, I think it's only 11 minutes of an arc, if I have the number correct. It's a very small arc, and he had observations, and then it became it disappeared into the flare of the sun. So every astronomer in Europe was desperately trying to use Newton's methods to figure out how to calculate what this orbit, the actual orbit of this new object was, from these very small intervals. And they were all making projections from that calculation as to when and where in the sky, if you were to point your telescope, you would see this planet, this object reemerge. They all came up with very different estimates. And Gauss, Carl Friedrich Gauss, who was a student of a man named Abraham Kessner, who in turn was a student of some of Leibniz's associates, and was a very strong advocate of Kepler's work in opposed to Newton. Gauss took it upon himself, he was a young man, I think in his very early 20s at the time, to make his own calculation. And instead of using Newton's method, he used Kepler's approach, and also with some new innovations that he himself invented. And out of that, Gauss came up with an estimation as to when and where this object could be seen. It was a completely different part of the sky than what everybody else has predicted. And sure enough, 8 months or 9 months later, astronomers pointed their telescopes where Gauss said, and there was the planet. And it became known as an asteroid, a planetoid named Ceres. And then shortly after that, there were 4 other big asteroids that were discovered. And now, of course, we know that there's a whole plethora of small objects moving around in this region between Jupiter and Mars. And that confirmed, that's what LaRouche means by it settled the score that Kepler's approach to astronomy was correct. And Gauss, of course, later went on to become the founder of many areas of modern science, on which basically all modern science depends. So that's a short, brief summary of this fascinating area of history, of science. and is completely, I mean, I went over it very quickly, but I can assure you that this incidents in science history can be learned and mastered by, and should be, by students, especially, I would say, really in the middle school. They should, by the time you get into high school, should be familiar with this, and you would develop a whole new generation of creative scientists. And once again, it shows that the universe, this was actually, all this was done before Clausius and Lord Kelvin came up with the idea of entropy. But of course, this is the idea of entropy and the universe running down was already a topic of discussion between Leibniz and Samuel Clarke, who was had power of attorney for Newton to argue with Leibniz on. So it's not, it didn't begin with the coining of the term entropy, but the idea that the universe was what LaRouche calls negentropic, anti-entropic, or another way to say it is alive, was proven by Kepler and Gauss to be the case. And so running away from that idea, science running away from that idea has set us back quite a bit.
Thank you.